Hello and welcome, guys. So this is going to be a video about the other solid principle, about Liskov Substitution Principle, or LSP. In this video, as usually, I'm going to show you a real-world example, so the chances are quite high that you're going to use something similar at your workplace. And this is going to be more of a coding approach. I'm not going to go deep into theory. And as a base of this video, I'm going to use actually my previous video where I fixed dependency inversion principle, because in that video we kind of fixed a lot of LSP violations as well, but we still have some other ones. So if you haven't seen my previous video, I highly recommend you to check it out. But if you haven't or not planning to, anyways, I will walk through the code quickly right now and explain where we are complying and violating LSP right now. All right, let's just jump into code. So in the previous example with dependency inversion, we assume that we have a refund service. For example, it's an e-commerce platform and we need to process refunds for some of the purchases our clients made. And we needed to make a platform that can handle both Stripe and PayPal refunds, or any basically payment service. But we assume that we have a PayPal and Stripe clients with completely different inputs. Like Stripe requires charge ID and amount, and PayPal required like payment percentage and transaction details with PayPal email transaction ID. And they were returning completely different responses. Like PayPal was returning transaction ID, payment percentage, and Stripe was returning like refund ID, amount. And yeah, so inputs and outputs were different. So in order to fix that, we created an interface, or you can call it a port, which is payment processor, and we created adapters for each payment provider, which essentially converted input into required like inputs we have in our refund service. So we provided all the needed information in form of refund request, which comes from the web, like transaction ID and amount we need to refund, and refund context is all the information we are getting from the database about this payment, and we just injected all of those to adapters. And adapters converted this input information into required inputs for each payment provider. And then we converted them into expected responses. So this is how we fix dependency inversion. And in many cases, we fixed already Liskov substitution principle. So let me add the definition of LSP here. So the official Wikipedia's definition is: objects of a superclass should be replaceable with objects of a subclass without breaking the application. Or in simpler terms, if we have a base class and we derived a class, we should be able to use any derived class whether the base class is expected, and everything should still work. And this is more of a object-oriented definition, because here we are using base class and derived classes, which means inheritance, and we are not using it here. But in our example, it means that we should be able to use in refund service any payment provider, and our code should not break. It should behave exactly the same way, right? And we almost achieved that by creating a port, right? This interface, and we say that any payment provider should have a refund payment. It should have these inputs: refund request, refund context, and it should always provide us refund response, yes? And we created a factory which gives us the adapter based on the type. Either it's a Stripe adapter for Stripe, yes, and PayPal adapter for PayPal. And then we just hit refund payment, yes, and then our adapter converts everything to specific implementation. For example, here in PayPal, we are getting all the needed like payment percentage. We are doing validations, and then we're just using PayPal client, refunding, and then we're converting PayPal's response to our specific response, which we are expecting. So we can use any payment provider at any time. We can switch them, replace them, as long as they comply with this port and they have adapter if they need it. However, there are still some problems with this implementation. All right, so I've placed PayPal adapter on the left and Stripe adapter on the right. And as you can see here, I highlighted that we have some business rules inside, and we have them in both adapters. So the first thing, we are checking that we are receiving the correct type, right? That we instantiated the correct adapter, just in case. It's the same for Stripe and PayPal. Then we are validating for PayPal that we are getting PayPal email because it is required by PayPal client. And if we are not receiving it, we should throw some error, right? If we need to show either to our client, or we need to have some internal policy that handles these scenarios if we didn't have PayPal email in our database and now we are requesting a refund. So this is some kind of missing information and we need to have a policy which handles it. And for Stripe, obviously we don't have it because Stripe has different inputs. It requires Stripe charge ID. And as you can see, we have the similar policy, but it's a different error, right? We need to show client, for example, that we require some Stripe information for this specific refund. And then PayPal has a policy, for example, yes, that if it's 180-day limit payment, we cannot process the refund. And for Stripe, let's assume that if amount is less than $25, we can't refund it as well. Stripe refunds only 25 and more. So as you can see, as per LSP, our subclasses or derived classes, they should behave exactly the same. But here we have different behaviors in terms of errors. The refund is okay for both of them, right? The success case is fine, but the error case validates the LSP. The next problem here actually is, I added it on purpose, that we are handling errors not by throwing them, we are just creating a refund response and then failure. And this validates both open-close and single responsibility principles, because we are handling error here, we are doing some mapping. So these now adapters are responsible for processing errors. And in case if we need to add more error scenarios, we need to go into adapter and adjust it, which violates open-close principle. All right, now let's go into fixing all of this and see how we can improve these adapters. Just a brief pause. If you enjoy this type of content or want to watch me live code projects like this, hit subscribe button and ring that bell. It is free, takes 2 seconds and helps me a ton. As you can see, only a very small percentage of you guys actually subscribe to my channel. Anyways, thank you very much for all the support. Let's continue. So since validations are essentially business rules and we cannot have them in adapter because adapter is essentially responsible only for converting input to another input, we're just gonna delete them from adapters for both PayPal and Stripe. So the question is where we're gonna place them. And the answer is we're gonna use something called specification pattern. And I will add straight away the specifications interface. So usually it has 2 methods, is satisfied by and a reason. So specifications are responsible for validation, and is satisfied by will handle the validation itself, and reason will be something that we will throw in case of an error. So the first specification will be Stripe provider specification. If you remember in a validation before, we were checking that we are in fact created the correct provider, right? So if we are trying to create Stripe payment provider and we didn't create the Stripe one, we will return false, right? And then we will check what is the value of is satisfied by. If it's false, then we will throw the error. And here we can customize these errors, right? I just created invalid provider and some metadata. Let's add the other ones. So we'll have Stripe data consistency. Here we will check that we in fact have in database charge ID, and now we will throw in case of an error missing data error, and we will specify which fields are required, right? And what is the provider. Then we will have the other one, which is PayPal. Basically the same thing for the PayPal. I'm not gonna go through it, right? Specifications for PayPal, and then we will have some common ones like transaction exists in case if we are missing some information in database, that we are in fact using the correct refund amount, so it's not less than 0. All right, let's see how we can use this now. And the first thing we're gonna do is actually create a specification factory. It's gonna be something similar to payment processor factory, where we were giving payment service type, in our case Stripe or PayPal, and we were returning the correct adapter, right? So in our case with specification, we will create a refund specification factory, which should return the array of specifications, the one I showed you just now. and then we will have some common specifications like default ones, and then we will have specifications for Stripe and for PayPal. And yeah, I added default case, we're returning just the common ones, but we can throw error here that we require payment provider, otherwise it's not going to work. So like common specifications, we will have something that checks that indeed we have this database transaction. So we're trying to refund something that does exist in database, or that we are in fact refunding the correct amount, right? So the amount of refund is not less than 0, and we are not asking to refund something which is greater than the entire payment. And yeah, in using this factory, we will create specifications now for each payment provider. And now the final step would be to add it into our service. This is going to be very similar to our payment processor factory. So we will create an interface for our factory, right, which has get specifications method. And I already implemented this interface before, and we have get specifications method. Now we will add it into our constructor, and then we will get all the specifications based on the payment type, right, which is either Stripe or PayPal, or we can add anything additional here. Then we will loop through all specifications and check if each and every one of them is valid. So if they are not valid, we will return here false. And if any one of them is false, we will await the reason. And reason is throwing error. For example, here, like each and every one of them throws the error. Here you can do it differently. It's up to you. We can just return the error class and throw it from our service. I've seen both ways. Well, it's up to you how you're going to handle it. But essentially, I'm just awaiting it here and throwing the error in the specification itself. And this is essentially specification pattern in work. So what did we achieve with it? So now we have all validations in our service, which is absolutely fine because service is our orchestrator and it should be responsible for this, especially since in our validations we had business rules. So our adapters and in essentially payment providers now responsible only for one thing, and they all will behave the same way, right? They're only refunding the payment. We can have one error here in case if our client fails, right? But it's going to be the same error. We know there is only one type. This actually still validates our principles, right? As I said, open, close, and single responsibility. We will refactor it now. But in terms of LSP, now we are good here. What about the specification pattern, the validations itself? So now all of them behave the same way as well. We will be either satisfied, so we do nothing, or we'll throw an error. And now we can essentially add or remove any specifications as we like, right? We can add more Stripe, PayPal, we can add here another payment provider. We will just adjust our factory and yeah, and we're good to go. So now all the validations are in single place. They're handled from service, which is the right place to handle business rules. And yeah, we are still violating some rules in our adapter, so let's adjust them. But in terms of LSP, we are pretty much done. Okay, let's refactor the response failure. Let's remove it completely. So we will remove response failure. We will actually remove try catch as well, because we will bubble up these errors up. We will remove it from Stripe as well. And we remove try catch. Now let's go to response, and now we'll just remove failure. I actually placed to do for myself. So now we have only success case, which is very good for both of them. Now let's go to here, and in our service we will remove as well validation as well, and we will remove try catch. So if we have an error, it will bubble up. If we have an error in our refund payment, it will bubble up as well. We can actually, it's up to you, we can try catch it here as well, right? And throw some specific error here, right? We can define a custom error here, but most likely you will handle errors in controller. At least this is how we do it. So I'm not gonna edit here, and I will just leave it like this. And I will allow our controller just errors to bubble up, and controller will handle them. So as you can see, now our service has become way clearer, and I think we are done with this service. So we are not violating any solid principles at all now. We are complying with single responsibility, open, close, LSP we just fixed, dependency inversion we did in a previous video. So this is pretty nice clean service. The only rule I didn't talk about is interface segregation principle. We are actually complying with it because we are providing only the methods we need. It's quite straightforward, so I'm not sure, maybe I will make a video about it, but probably not. In any case, I hope you enjoyed this series. I hope it was helpful. I tried to show real-world examples. And yeah, thank you very much for watching. I will see you next time. Take care, guys. Bye-bye.